Hello everyone, my name is Brian McCabe. I'm an Associate Professor in Civil Engineering at NUI Galway. I'd like to draw your attention to an SFI funded project which aligns well with the goals of the peat project. This project will investigate the ability of surcharging, which is a form of ground improvement used in geotechnical engineering to reduce secondary settlement in peat soils. The engineering context for this research is that the Department of Transport has committed €8 billion to Transport Infrastructure Ireland in this decade for the construction of new and the maintenance of existing roads. And given that approximately 14% of the land area of the Republic of Ireland is comprised of peat, it's inevitable that peat will be encountered on these future road schemes. From an engineering point of view, peat is problematic in terms of its low strength, high compressibility and variability. And where present in thicknesses up to about 4 metres, current practice on road schemes in Ireland is to excavate and replace peat with a more competent fill material, with the well-known environmental consequences of carbon release into the atmosphere. For example, Duggan et al. 2015 have quantified the embodied carbon associated with the construction of a motorway over peat in the west of Ireland as approximately 8 kilotons of CO2 equivalent per kilometre, with carbon release from peat being the biggest contributor. Surcharging is a form of ground improvement which involves the application of a temporary overload to reduce settlement in service. It's a cost-effective ground improvement option where technically viable and has the benefit from an environmental point of view of leaving the underlying soil in place. The technique is well established in mineral soils, but largely unproven in highly organic soils. And Transport Infrastructure Ireland Series 600 for earthworks doesn't permit this technique to be used in Ireland for road schemes. This project provides an opportunity to influence both national practice through TII and international practice with potential for large environmental benefits. The schematic on the left shows peat subjected to road embankment loading. It also shows the temporary surcharge level, which is higher than the final level. The diagram on the right illustrates the corresponding stress-strain relationships for primary consolidation, starting with an initial stress before embankment construction, then the surcharge stress, which represents what we call a normally consolidated state, before unloading to final level, leading to the soil becoming over-consolidated. We can define the adjusted amount of surcharge as the surcharge stress minus the final stress divided by the final stress. In terms of vertical strain variation with time, we have two phases of settlement, primary and secondary. Secondary settlement or creep is significant and often dominant in highly organic soils such as peat. We can quantify the creep rate C alpha for the normally consolidated state corresponding to the surcharge level. Then, when we remove the surcharge, we can quantify C dash alpha for the over-consolidated state. Based on experience with mineral soils, our hypothesis is that C dash alpha will be less than C alpha and that the ratio between them will be a function of the adjusted amount of surcharge shown on the previous slide. The hypothesis will be investigated using 3 strands. The first is odometer testing, a form of compressibility testing, a simple version of which is shown in the photo on the right. Key challenges will include minimizing sample disturbance and limiting or preventing a possible peat degradation over time, given that these are long-term tests. We expect to produce a bespoke version of the odometer to accommodate greater thicknesses of peat, given its high compressibility. In addition, there will be some field trials, including monitoring of a section of the N56 road scheme near Glenties in County Donegal. Finally, there will be a numerical modelling component which will verify and extend the applicability of the lab work. Plaxis final element modelling software will be used in conjunction with its soft soil creep constitutive model. This slide shows the project team. It's funded by Science Foundation Ireland through ICRAG 2 And we're fortunate to have a number of industry stakeholders, including Transport Infrastructure Ireland as the public body, Wills Brothers as a civil engineering contractor, and three consultants, JB Barry and Partners, RPS Group, and Rowan and O'Donovan. For anyone interested in contacting me or finding out more about this project, I'd be delighted to hear from you using the details shown.